For more videos and problems like this for Intro to Financial Management 301, you can check out Sarai Studies, link in the description box below. In this video, we're going to talk about delayed payments or delayed cash flows. And we're going to start with what you already know, and then we're going to transition into what's new. So this is something that you can already do. They're asking, what is the present value of an annuity? So you know that your annuity formula is C over R, 1 minus 1 over 1 plus R to the T. You get that from your formula sheet, and that's going to be equal to the present value of whatever investment. So let's draw a picture. So that annuity pays $100 a year for 10 years. So this is time 0, present time. So for 10 years, year 1, year 2, and all the way until 10 years, this annuity is paying $100. So in year 1, it pays $100. In year 2, it pays $100. Year 3, it pays. Year 4, 5, and so on. And all they want to know is how much all of this money is worth today in the present. So they're telling us it's an annuity, so let's just plug in our numbers. So C is our cash flow, how much cash is coming in each year. It's $100. Our rate is 5%. We have to put it in decimal, so just take your calculator, divide by 100 to get your decimal, which is 0.05. The rate is here as well. And then time, how many years are you going to get paid? 10 years. And if you put that into your calculator, you'll get $772.1735. So this is telling me that all of this money, when we discount it using our annuity formula, is worth $772 at time 0. So all of this is worth this today at time 0. Great, we already knew how to do that. Let's try this one. This is the exact same thing. The only difference is that instead of them starting to pay you $100 exactly 1 year from today, from time 0, they're now going to start paying you 3 years from today. So if this is today, time 0, and this is year 1, they're not paying you $100 in year 1, nor are they paying you $100 in year 2. They're saying, we're going to start paying you in year 3. Then that's $100, and it's going to go on for 10 years. So really 3 plus 10, that's 13. So year 4, year 5, 6, all the way to 13. The annuity is going to pay you $100 each of those years. And so it's the same question, how much is all of this worth today? So you would do the exact same thing as if it wasn't delayed, as if it was starting 1 year from now. And you would just plug in your stuff into your annuity formula, you would get this, but then the difference lies here. This does not represent your present value at time 0. The value of all of these cash flows today. This represents the value of all of these cash flows 1 year from the year that you started receiving the payments. So you started receiving the payments year 3. So when we do the annuity formula, that discounts back to 1 year from when we started receiving the payments. That's year 2. And that's been true the entire time. We just kind of never paid attention to it. But that's the rule. All of these shortcuts, they don't give you the present value at time 0. They give you the present value of all of these cash flows 1 year from the year you started receiving payments. It just happened to be that up until now, we had been receiving payments exactly 1 year from now, so 1 minus 1 is 0. In this case, we start receiving payments 3 years from now, so when we take our annuity formula, that discounts 1 year before the one we started receiving payments. So 3 minus 1, that's 2. So this is really the present value at time 3. So if we move in time to year 2, this is how much all of these cash flows are worth in year 2. But looking from the perspective of today at time 0, this is really considered a future value because it's in the future. But remember that our goal is to find the present value of this investment at time 0. So we have this, we have a future value. So how about we just discount to find the present value at time 0? That's a topic 3 small little formula that you will have on your formula sheet anyways. So it's literally this number, 772.1735, divided by 1 plus the rate, which is 0.05 in decimal, and then it's time 2. That's going to give you the present value of all of these cash flows at time 0. That's $700.3841. That means that all of these cash flows today at time 0 are worth that amount of money. But at time 2, at year 2, it was worth $772.1735. So all we did was just discount that. That's what this was.